Hello and welcome to this tutorial. In today's video, I'm going to show you how you can use MATLAB Simulink to have the characteristic of a diode. In this circuit, we have a special circuit to make the characteristic of a diode using an alternative sources and also a diode and a load which is of a resistor component. Here we have also the measurement component. We have the voltage measurement, the current measurement, and the voltage measurement of a diode, and the voltage measurement of the load. The different components, different measurement allow us to measure the different parameter in this circuit. Of course, the voltage of the input. We have also the current which pass across the diode and the load, and the output voltage, which is the voltage of the load. We have also the voltage of the diode. In this diode or in the other components, we can make some setting of different parameters. Like for example, if we can start with this AC voltage source, we can make change, double click, and make change if you want on the peak amplitude of the voltage. Like for example, like let's take 200, for example, 200 volt. Okay, here in the diode we can make change, of course, if your diode is an ideal diode or a diode with a forward voltage. Let's start with an ideal diode with a forward voltage of 0 volt. Okay, and the last part we have the load. In the load we are making a R load, just a resistor. Okay, we can make the value of the resistor, double click on the load and specify the value of the resistor. Okay, start, click OK. Then we have the voltage, the current, okay, the voltage output and the voltage of the diode. To make the simulation, before starting or putting run simulation, specify your simulation time. Okay, here we have just 0.1 second as the time in the x-axis. Okay, and of course we have to add a special component or special block in this simulation, this MATLAB model, which called power key. The power key allow us to specify the time of each measurement, the simple measurement. Here we have each time of 60, 40 or 50, 10 minus 6 second will take a measurement. Okay, here the different, here are like a general description of the circuit. Okay, let's start the measurement. Click run simulation. Here in the scope we can visualize the different components in the scope. Firstly, the first one is the voltage of the AC source, the input. We have as second the voltage of the diode. We have the current in the diode, and finally the output voltage. Double click on the scope to visualize the different parameters. Here we have the different parameter. This is the input voltage. Input voltage is an alternating voltage, okay, which have some positive and negative alternance in a period of, this is the period from 0 to 0.02 second. The period is about 0.02 second. Okay, let's start firstly with the output voltage. This is the characteristic of the diode. This is of course the output voltage, not the characteristic of a diode. The voltage on the diode is this one, the second input, because here the first one is the input voltage, the second one is the voltage on the diode. Here we have an applied voltage applied in the diode, here a negative voltage applied in the diode. When the positive uh, voltage is applied in diode, then in this case the diode will allow current to pass across the diode. In this situation, as the diode is ideal, the voltage between the different pole of the diode is zero. This is the result. Here we have zero in the voltage of the diode. In the second part, the voltage applied in the diode is negative because we have the negative alternance. In this case, the diode is blocked. Okay, the diode is blocked. As a definition of the block of the diode, the voltage between the diode is negative. Okay, the polarization of the diode is negative. This is the difference between the first part of the period and the second part. Here we have zero in the voltage between the different pole of the diode, and we have negative value under negative alternance. Okay, the third result is the current across the diode and the voltage across the diode. Let's start with the voltage, the last one. For the voltage, when the diode is passed, the output voltage equal the input voltage is the same, 200 volt. Here we have 200, also 200 volt. Okay. When the diode is blocked, the output voltage equal zero. Why? Because when the diode is blocked, is converted as an interrupter open, okay, which blocked the current. Here the current which will be passed across the diode will be zero, and the output voltage is a resistance, okay, a resistor. Here the output voltage based on Ohm law, okay, equal R time the current. The current equals zero. Here the voltage equal will be also zero. It is the result. Okay. And for the current take the same chip of voltage. The difference is just in the value, in the maximum value of the current. The maximum value of the current is 20. 20 compared with 200 is divided by 10. This 10 is of course the value of the resistor. Okay, the value of the resistor. Let's take a special comparison here. If, for example, we take like a low value 5. Okay, start simulation. We'll have the same result. Okay, have the same result. I want to show you if we have the forward voltage in the diode. For example, we have 0.7 as for silicium diode. Okay, so here not ideal situation. Here is the diode with a value of forward voltage. Like, click run simulation again, and here the result. Okay, so this is the input and this is the output. Okay, here you can remark that we have, when the input voltage is positive, the output voltage until a special time equals zero, then the value began to increase. This is the effect of the forward voltage. Let's take a special zoom on just one period. Here the result. Here we have the output, the input, of course, the input voltage, and here we have the output voltage. Why this? It equals zero. It's equals zero because the diode will let the current pass across the diode until the input voltage equal the value of the forward voltage, which is 0.7. If we take, for example, here the value, we can take 0.7 until this point. We can take the intersection with the input voltage and make some projection. In this projection, we will start to let current passing across the diode. Okay, here like a comparison between the characteristic of the diode when the diode is ideal without the value of the forward voltage. Okay, this is the second situation, and the first situation which we have already discussed when the diode is ideal without forward voltage. Thank you for watching. See you later.